Good morning, dear students. Now, let's discuss the next topic, which is related to Raoult's law, and that topic is azeotropes. Azeotropes are also known as constant boiling mixtures. Now, what is the meaning of azeotropes? In 11th class, we have learned that if we have a mixture of two liquids, we can separate two liquids by the process which is known as distillation. And that process is based on the concept of boiling point. If the boiling point difference is more, we can use simple distillation, but if it is less, we can use fractional distillation because the two liquids will boil at different temperature. The liquid which has less boiling point will vaporize first, and then the liquid which has more boiling point. But what are azeotropes? Azeotropes are the solutions. They are also liquid mixtures, but they boil at a constant temperature. So both the liquids boil at a constant temperature, and since the two liquids boil at constant temperature, we cannot separate the azeotropic mixture by the process of distillation. So the solutions which boil at a constant temperature and can distill unchanged in composition are called as azeotropes. So in azeotrope solution, the two liquids will boil at a constant temperature, and it is not possible to separate them by the process of distillation. Now, on boiling, these produce vapor with the same composition as the liquid. Okay, and these cannot be separated by fractional distillation. Now, there are two types of azeotropes. The first is minimum boiling azeotrope and the second is maximum boiling azeotrope. Now let's discuss them one by one. Now first is minimum boiling azeotrope. Now minimum boiling azeotrope is formed by the solution which shows positive deviation from Raoult's law. And we have learned that when the solution shows positive deviation, the partial vapor pressure of each component is more than that expected from Raoult's law. PA is greater than P naught AXA, if you remember. So what will happen? For such solutions, since the vapor pressure of solution increases as compared to the ideal solution, and there is a relation, vapor pressure is inversely related to boiling point. So if the vapor pressure of solution is more than expected, what will happen? The boiling point of such solutions will decrease, and that's why such azeotropes are known as minimum boiling azeotrope, because such solutions have less boiling point than either of the two components. Now one example I am taking here. The first is ethanol and water. Now ethanol and water show positive deviation. Boiling point of water is 373 Kelvin. Boiling point of ethanol is 351.5 Kelvin. Now at certain composition of ethanol and water, vapor pressure will be highest. Okay, so I will mix ethanol and water together and there will be one intermediate composition, and at that composition the vapor pressure of solution will be maximum. Therefore the boiling point of that composition will be least. And what is that composition? Where the vapor pressure of the ethanol solution is maximum, and that composition is 95% ethanol, which is also known as rectified spirit. So this 95% ethanol behaves as an azeotrope. It is minimum boiling azeotrope. It is having least boiling point, and this 95% ethanol, it is obtained by fermentation of sugar. Okay, so fermentation of sugar gives both alcohol and water, and if we distill it, water is removed, but that composition can be reached only up to 95% ethanol. Afterwards it cannot be distilled further to separate water. So this is your minimum boiling azeotrope. Now the second is maximum boiling azeotrope. So it is formed by solution showing negative deviation. Since the solution shows negative deviation, the vapor pressure of the solution will decrease, and therefore such solutions will have more boiling point than expected from ideal behavior, and that's why they are known as maximum boiling azeotrope. For example, HCl and water. Water has boiling point 373 Kelvin. HCl has boiling point 188 Kelvin. Now they form an azeotrope at the composition of 20.2% HCl. So when the composition is 20.2% HCl, it will form an azeotrope, and it boils at a constant temperature of 381.6 Kelvin. So this is all about the azeotrope. Now there are some conceptual questions. You try to solve these questions. Now the first question is, two liquids A and B boil at 145 degree and 190 degree respectively, which has higher vapor pressure at 80 degrees Celsius. The second question is, mixing of acetone and chloroform takes place with reduction in volume. What type of deviation from Raoult's law is shown? And the third is, can we separate the components of azeotropic mixture by distillation? So these are three conceptual questions. Now moving on to the next part is colligative properties. Now what are colligative properties? These are the properties of dilute solutions containing volatile solvent and non-volatile solute, which depend only on the number of particles of solute and not on the nature of solute. Number of particles means number of moles. Now these properties are 4 in number: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So in the next class we are going to discuss these properties in detail.